This is section 1.5, and we're continuing on with slope. We're going to really be focusing on parallel and perpendicular lines today and rate of changes. Let's go ahead first and talk about parallel and perpendicular lines, and we'll take a look first at some parallel lines here. Now, looking at these parallel lines, I hope you're noticing that they both have some slopes written in here, and it looks like this one is 2/6 and this one is also 2/6. So hopefully you might remember, or you can see just looking at this picture, that the slope of these parallel lines is the same. They're both 2/6 or 1/3. And so you'll notice that they're the same. And basically what I wanted to remind you is that parallel lines have the same slope. If two lines are parallel, their slope is the same. Let's go ahead and take a look at an example here. I want to write the equation of a line passing through this given point, and I want it to be parallel to y equals 2x plus 1. Since it's parallel to 2x equals 1, I know I want its slope to be 2 because it's the same as this line here, and I want it to have that point there. Now, remember I told you that we would find a use for point-slope form? Here is a perfect example. You can see that it only asks us for an equation. It doesn't specify what kind of equation it wants. So really, we could just take our point and our slope and put it in point-slope form. We can say y minus 1 equals 2 times x minus negative 3, which is x plus 3. This right here is a perfect answer in point-slope form, and we could leave it just like that if we wanted. Now, some of you may say, Mrs. Alberg, I really prefer my equations in slope-intercept form. If that's the case, then you could go ahead and take the 2 and distribute it. So we'd have y minus 1 equals 2x plus 6, and add 1 to the other side, and you'd have 2x plus 7. This would be the same exact equation, only now it's in slope-intercept form. And that would be a great answer as well. Now, one other way that you could solve this question would be to start with your equation instead in slope-intercept form. So you could say, you know what, let's take y equals mx plus b, and let's plug in the 2 because I know that's going to be my m. So 2x plus b. And try to figure out what the b value is going to be. Well, since we know there's a point, I could plug that in for y and x, and I could solve this way. This is one way you might have done this equation, say, in geometry. So we have 1 equals negative 6 plus b, and when you add 6 to both sides, you can see b equals 7. So then you can fill that in. Y equals 2x plus 7. And you notice the same answer as I did in purple. Now, this method is great, but you can see it takes a lot more work than if I had just used the point-slope form like we did in the beginning. You can do it either way. Whichever you prefer is fine. Let's talk about perpendicular lines now. Does anyone remember about slopes of perpendicular lines? If you don't, let's take a look at the graph first and see. If you do, you could fast forward ahead. If I look at these two slopes, it looks like one of them here is 3/4, and the other line goes the other way, and its slope is negative 4/3. So we have one that's negative 4/3, and we have the other is 3/4. And the main idea there is that these are the opposite reciprocals. Change the sign, flip the fraction. Opposite reciprocal slopes. So if you're given a line and you want the slope of a line perpendicular, you just have to change the sign and flip the fraction. Taking a look at example, we're given a point and a line, and we want the line perpendicular to it. So we're going to go ahead and first find the slope of the line they give us. Now you'll notice that this equation is in general form, so it's going to be a little more work to solve. The first thing we want to do is solve for y, get the y alone so we have the slope. I'm going to add 8 to both sides to do that. And I have x plus 4y equals 8. Subtract an x. And I have 4y equals negative x plus 8. And then divide by 4. And we have y equals negative 1/4 x plus 2. Now remember, really all I need out of this equation is the slope. This time though, I'm not using the same slope because we're not perpendicular. I need the opposite reciprocal slope. I'm sorry, because we're parallel, I need the opposite reciprocal slope to be perpendicular. So I'm going to take the opposite reciprocal of negative 1/4, and I get an answer of positive 4 when I flip that and switch the sign. So now I have my slope and I have my point, and I can write the equation of a line. Once again here, it doesn't specify, so I'm just going to stick with point slope form because it's real fast and easy. I'm going to say y minus negative 5, so plus 5, equals 4 times x minus 3. You could leave your answer just like that in point slope form because we're not specifying, all it says is equation. Or you could distribute your 4 if you really like to and add 5 to the other side and get y equals 4x minus 17, and that would work just as well. That line is perpendicular to the one we're given, and it goes through the point 3, negative 5. So now I want you to answer this multiple choice question. I want to know the line parallel to the one given that goes through the point 4, negative 5. This answer will go in the Google form, and then you can continue on with your video. The second thing I want to discuss in this video is a reminder that slope is going to be a rate of change, and that's how it relates to the real world. It's a rate of change. So just taking a look right now, we'll just look at this graph for a minute. You don't have to really write anything on this slide. You can just listen and watch. Now, there's a line here, and it represents the percent of U.S. adults who smoke after X years after 1997. You can see that if we take 2.0, now remember 0, this would be year 1997, and this 10 would be 10 years later, you can see that the rate went from 24.7 to 19.5, so there was a decrease. If I actually calculate the slope, I get negative 0.52 as my answer, and it should be negative because it's a decrease. So what I want to know just is, what does that represent? And the key here is that it means that the percent changes by 0.52 every year. It goes down by 0.52 every year. So the amount of people who smoke goes down by 0.52% each year. So just remember that slope is really just the rate that something's changing, the rate per year, or the rate per day, or the rate per month, depending on what your X value stands for. Now, the last thing I want to talk about is more about average rate of change, and now we're going to say function as opposed to the word line. The reason is because a function is not always a straight line. We need to know how to find the average rate of change if it's not a straight line. And basically, if you take a look at this picture, your rate of change is your slope is going to change depending on what 2 points you pick. So when you're finding rate of change of a function, you really have to determine which two x values you want to look at. And from there, you'll just calculate their slope. You'll find the change in the y's and the change in the x's. So you can see here, taking a look at 3 different x values and 3 different y values, the slope of the secant line through the point 1,383, depending on what my other x value is, it changes accordingly. So it's going to change as you go through, depending on what your 2 x values are. So in order to find the rate of change of a function, we have to be sure that we're given some x values. So our function here we're going to look at is f of x equals x cubed, and you can see that that's drawn there. We all know hopefully what a cubic graph looks like. Now, Remember, I have to give you two different x's. So in this case, A, I want to find the rate of change when x is 2 and x is 3. The first thing I'm going to need is their y values. So I need to know what is f of 2 and how much is f of 3. Well, 2 cubed is 8 and 3 cubed is 27. So I have two x values and their corresponding y values. Now all I have to do is find the slope, the change in the y's. We'll say 27 minus 8, and divide that by the change in the x's, 3 minus 2, and you can see the answer here is 19. So the average rate of change when x is 2 and x is 3 is 19. And you can do the same thing for all of these. So the same thing for when we want to go from 3 to 4. F of 3 is 27. F of 4 cubed is 64. And I do the same thing. I can subtract the y's and I can subtract the x's. 64 minus 27, 4 minus 3, and we're going to get 37 over 1. And again, it changes. Let's take a look at one more. We need to find f of negative 2. We want to know the average rate of change between negative 2 and positive 2. So negative 2 cubed is negative 8, and 2 cubed is 8. So we'll subtract the y's. 8 minus negative 8. We'll subtract the x's. 2 minus negative 2. So we get 16, 8 plus 8 over 4, which equals 4. And the average rate of change between those 2 points is 4. So just remember, when you want to find the average rate of change of a function, it's going to be different. You can see here we got 3 different answers because it all depends on your given x values. Here's your free response question. You're finding the average rate of change of this function, and here are your 2 given x values. And you can put this answer in your Google form, and then you're done for the day.